Hello students, how are you? Welcome you all into the Jaswal Edu Maths. Today we are going to do some concept or topic of determinant here. We learn about the cyclic determinant. First we talk about how cyclic means. You see here that A, B, C are in cyclics. That means you always find the relation like A, B, B, C and C, A. Okay, or A minus B, B minus C, C minus A, or A plus B plus C, A B plus B, C plus C A. So this is called cyclic relation always. So how would you perform or where do you see the question like this? The questions are 1, 1, 1, A, B, C, A square, B square, C square. Okay, if the elements of the row or column are in cyclic order, if the elements of row or in column in cyclic order, then it is called cyclic determinant. So here you see that A B C, 1 1 1 in the first row, A B C in the second row, A square, B square, C square in the third row. So how would you solve this question? So in order to solve this question, we need to first make this and this element. That means this is the element of A12 and A13. Make two elements 0, like A12 and A13. So either you can make make A11 0. Okay, in order to simplify this, either you can also simplify directly, but you have to use the property of determinant in order to simplify it. That means after doing simplification like this, if you make this 0, then when you expand it, then the solution would be easy. Like how can you make this 0? When you subtract this minus this. Okay, so this would be C2 minus C1. So what you can do here, C2 change to C2 minus C1. Okay, now C1 is not changing here. Okay, so you can also apply this here. C3 change to C3 minus C1 also. Okay, because C1 is not changing, that's why I am doing the two properties at a time. Okay, we can apply because we are applying it on C1. So here we would get C is not changing, the column 1, C1 is not changing here. So 1 minus 1 would be 0, B minus A, okay, B square minus A square, okay, here 0, C minus A, C square minus A square. Now this is equivalent to, now the expansion is very easy. How would you expand? Expand through row 1. How? Okay, 1, write 1, this is plus. First the rule is, first you have to write plus, minus and plus, plus, minus and plus. Okay, all right. So this is the plus 1, then remove this row and this column. That means row and corresponding row and corresponding column. So you get here B minus A, B square minus A square, C minus A, C square minus A square. All right. When you expand this, what would you get? Okay, minus 0, then 0 multiplied by this determinant, the answer will be 0. Then plus 0, 0 multiplied by this determinant, the answer will be 0. So only this is the only solution. Okay, so this makes easy our expansion. Okay, when you made this 1 1 or A12 or A13 as 0. Okay, so now we are going to expand. So left cross minus right cross, B minus A, C square minus A square, minus C minus A into B square minus A square, C minus A into B square minus A square. So what would you get here? Nothing. When expand this C minus A, C square minus A square, it would be C minus A, C plus A, B minus A, C minus A, C plus A, and minus c minus a. Expand this, b square minus a square. When you expand this, b minus a and b plus a. Okay, take out now common this factor c minus a, alright, and b minus a. You factor it out, b minus a and c minus a. What would you get? C plus a here and b plus, sorry, minus b plus a. That means minus b minus a. So when you subtract this, you'll get b minus a, c minus a, c minus b. Okay, so this is actually cyclic. So the solution is cyclic here, b minus a, c minus a and c minus b. So when you make the order, it would be a minus b, b minus c and c minus a. Okay, you can b minus a minus b, you can do it like this, a minus b, when you take common minus. Okay, here take minus common, you would get a b minus c and then c minus a. Isn't it like cyclic? How? A, b, c, a minus b, b minus c and c minus a. You are getting the answer like this. So that's why we call it as cyclic. Okay, so we have many questions like this, but the procedure for all the questions are same. Okay, here the procedure is same for all. So I'm going to write some question here for you, you can solve it. This is 1, 1 and 1, a, b, c, a cube, b cube, c cube. And when you solve this, okay, after applying same rule what I have applied in the previous question, like I have made this and this element 0. How? By subtracting r2 change to r2 minus r1 by applying property, and r3 change to r3 minus r1. Okay, you will get what? A minus b, b minus c, c minus a plus b plus c. Here you have to use the property what? A cube minus b cube identity. Okay, where you know that a minus b in first bracket, a square factor. When you factorize this, you will get here a square plus ab plus b square. Okay, here you use this because you'll get here b cube minus a cube and c cube minus a cube. Okay, the second, now the next question is a, b, c, b, c, a, c, a, b. Okay, so how would you solve this? Because you are not getting any cyclic order. Okay, so isn't it? So in order to solve this question, remove this first. You can do one thing here, c1, c2, c3. When you add c1, this is c2, this is c3. When you add, apply this property, c1 change to c1 plus c2 plus c3. What you will get? You will get, after applying, okay, you will get a plus b plus c, a plus b plus c again, a plus b plus c here, and b, c, a, c, a, b. Again, you know that this is actually a multiple of a plus b plus c. This column 1 is a multiple of a plus b plus c. Then you can take out this. Okay, so what would you get? You would get here a plus b plus c out, multiple out, and you will get here 1, 1, 1, b, c, a, c, a, b. Again, you got the question like this. What do you have to do? You have to make this element and this element 0. How would you make this? You can apply here. I thought I told you C2. I think here wrong. I think this is R. What this R2 change to R2 minus R1 and R3 change to R3 minus R1. Okay, so you will get the value. So apply R2 change to R2 minus R1 and R3 changes to R3 minus R1. All right. I think I have done something wrong here. In the previous question, I have told you something R1 minus R2 instead of C1 minus C2. So correct that. Okay. Now when you apply this, you'll get here what? Here 1 B C, no problem in the row 1, but here you get 0 0, C minus B, and here A minus C, here A minus B and B minus C. Okay, you applied this property here. Now expand it through column C1. So what do you have to do? You have to apply this plus, minus and plus like this. Okay, but since you have to expand this along C1, so you have plus 1, okay, plus 1, remove this row and this column, you would get C minus B, A minus C, A minus B and B minus C. Okay, and I am not including the element 0 and 0 here, because when you include this, when you expand through this here, so we'll ultimately get answer 0. That's why. So you can write here minus 0, then remove this, but ultimately you'll get answer 0. So I'm only answer is this. So expand this, left cross minus right cross, C minus B, B minus C, okay, minus A minus B, A minus C. Okay, here. So what is this? C minus B, A minus C, A minus B and B minus C. All right. So you are not getting anything common here. What would you get? Okay, just multiply it. CB. Okay, I hope you are able to watch. Okay. CB minus C square minus B square minus plus BC. Okay, here when you expand this, you have to place bracket here, A square minus AC minus BA plus BC. Okay, when you solve this CB, okay, first open this bracket, so it would be minus A plus AC plus BA and minus BC. Here minus BC and plus BC will be cancelled out. Okay, and what about, nothing is there, I think. So here you can write here AB plus BC plus AC, AB plus BC plus C minus this. Okay, AB plus BC plus AC minus A square minus B square minus C square. Isn't it cyclic? Yes, the answer is cyclic here. Okay, this is the answer. So I have left this, so you have to also include here, and you are A plus B plus C. Okay, so here you can include A plus B plus C, A plus B plus C. All right, A plus B plus C. Now, where is the duster? Give me 2 minutes. now we have different questions also. So this is the way how you solve or eliminate or convert the elements 0 after applying a row operation and all, you know. Now we have, okay, now we are moving to the application of determinant in geometry. So application of determinant in geometry. So what are the application? First we have to move. The application are area of triangle if x1 y1, x2 y2 and x3 y3 are 3 points, okay, or you can say that they are the coordinate of like a triangle ABC, okay, suppose they are coordinates. So the area of triangle will be area of triangle, okay, will be like this, half of, okay, x1 y1, not x1, sorry, x1 x2 x3, x1 x2 x3 in the first column, y1 y2 y3 in the second column, 1 1 1 in the third column, close it. Okay, when you expand it, what would you get? Mod of half in a cyclic order, x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2, okay. You will get answer in square unit. So x 1 2 3 2 3 1 3 1 2, all right, this is in cyclic. So keep this thing in mind. The second application is or you can do the question related to this. Here we have the question, if 2a 2b 2c x1 x2 x3 1 1 1, okay, is it okay, y1 y2 y3 also, y1 y2 y3, okay, equal to abc upon 2, okay. If it is there, it is not equal to 0, then the area of triangle whose vertices are, you have to find the area of triangle whose vertices are what are the vertices here? x1 upon a comma y1 upon a, x2 upon b comma y2 upon b, x3 upon c comma y3 upon c. This is the question. If you want to solve this question, pause your video and try to solve. So here we have area of, we need to find, so we have the formula that whenever you have the vertices of triangle, you can apply the formula. So okay, now we are going to apply the formula, and the formula is okay, half, yeah, this x1 upon a, x2 upon b, x3 upon c, okay. Now you write y1 upon a, y2 upon b and y3 upon c, and 1 1 and 1, okay, all right. This is the area of triangle, area, okay, area of triangle. And we need to solve this. So how would you approach this question? So here we have 1 upon a, you can take out 1 upon a, 1 upon b, 1 upon c. I can write here, like at the place of 1 1 1, I can write a upon a, here b upon b, here C upon C, so that I could take multiples common. Here the row 1 is multiple of 1 by A, okay, the common multiple, you can take it out. In row 2 you have common multiple 1 by B, you can take it out. In row 3 common multiple 1 by C, you can take it out. What would you get? You would get here, it is equivalent to here mod of like 1 by 2 A B C, like this. You can write x1 y1 A, x2 y2 B, x3 y3 C. Alright, what do you have? Okay, this is x1 x1 x2 x3 x1 x2 x3 y1 y2 y3 y1 y2 y3 A B C. Okay, so here we have the condition, so remove this. Now we are moving to the condition and manipulating the condition first. Okay, since it is given here, I am going to use this. In the column 1 we have multiple of 2, so it can take it out. So what would you get here? 2 times A this, okay, and when you transpose this 2 here, you could get 2 into 2, okay, it would become here A B C upon 4. Alright, now you need to find what? x1 x2 x3 at the first column. So okay, move it. Okay, when you move it, when you apply C1 interchange C2, you'll get here minus sign. So here you'll get x1 x2 x3, and here at the place of column 2 A B C. Okay, now in the column third you need what? In column second you need y1 y2 y3, and column third A B C. So remove apply here interchange. What would you apply? Apply C1 C2 interchange C3. Okay, when you interchange this again, you'll get what? Minus, again minus. Okay, because you know that the value of determinant gets changed here. Okay, you know this. So it would again, you get here y1 y2 y3, and here A B C, and minus 1 minus will become plus. So this value will become here to A B C as here A B C upon 4. Okay, this value. Okay, all right. So A B C upon 4, when you solve this, you would get answer as 1 upon 8. So 1 upon 8 is the answer. Thank you. Now we are moving to the next property of determinant, and not property, sorry, the application we are doing this time. So condition of collinearity. So condition is this: if 3 points are collinear, then the area of triangle will be 0. Okay, so previously what we have done, we would equate this equal to 0. So 3 points, suppose x1 y1 x2 y2 and x3 y3, and if they are 0, they are collinear. That means if they are on the same line, okay, so area of triangle would be 0. All right, next one is equation of straight line passing through 2 points. Okay, equation of straight line passing through 2 points, like let 2 points are x1 y1 x2 y2 are the are the points. When you join this, you will make a line. Okay, suppose pxy is the point on the line joining. Okay, so what is the question here? That means you have equation of straight line passing through 2 points. The two given points are x1 y1 and x2 y2. When you join these 2 points, you will make a line. Suppose pxy be the point on this line. So we have equation of straight line. How? So the equation of straight line is equation of line. equation of line equal to, what do we have to do? X, x1, x2, what? X, x1, x2 in the first column, y, y1, y2 in the second column, 1, 1, 1 in the third column equal to 0. Okay. The question, find the straight line passing through the point A31 and B93. Okay. So the question is the equation of line passing through the point A31 and B93. Okay, A31 and B93. Alright, suppose PXY be the point on the line joining AB. Okay, so here equation of line is what? X, x1, x2. So what is x here? X is 3, sorry, x, what is x1 3, x2 is 9, y, y1, y2, what is y1 is 1, y2 is 3, and 1, 1, 1 equal to 0. Now we have to expand this. How would you expand? You need to first plus, minus, plus. I am expanding it through row 1. Okay, so here plus x, remove this row and this column, you will get 1, 3, 1, 1, minus y, remove this row and this column, 3, 9, 1, 1, you will get 3, 9, 1, 1, plus 1, remove this row and this column, 3, 9, 1, 3, 3, 9, 1, 3 equal to 0. Here x, left cross minus right cross, 1 1 ja and 3 1 ja 3, minus y, 3 minus 9, okay, plus 1 here, 3 is 9 minus 9 equal to 0. So you will get minus 2x, here you will get here minus 6y plus 6y, right, and 9 minus 9 0 equal to 0. You know, take common, minus 2 as common, minus 2 x plus, sorry, x minus 3y equal to 0 implies x minus 3y equal to 0 is the equation of line. Alright. So here is the application. Now let's talk about the Crammer rule. Okay, so when we apply Crammer rule, we talk about the system of linear equations and its solution. So suppose we have system of linear equations, a1x plus b1y equal to c1, a2x plus b2y equal to c2. Okay, this is, so here you see that this is homogeneous or non-homogeneous. This is non-homogeneous because you have the constant which is not equal to 0, so this is not non-homogeneous. So and the determinant would be, the case is that here when you find the solution, x would be d1 upon d and y would be d2 upon d. Here d should not be provided, right, provided d should not be equal to 0. Then what is d and d1 and d2? D is actually determinant, okay, what of a1 a2, the coefficient of x here, and b1 b2 coefficient of y. What is d1? Remove here the a1 a2, that means exchange a1 a2 as c1 c2 here, c1 c2, okay, then b1 b2, and d2 exchange what, at the place of b1 b2 write c1 c2, this is the constant, a1 a2, okay, c1 c2, these are alright. So here provided a d should not be equal to 0. Now we can talk about also the system of linear equation of 3 variable. We have 2 variable in this case, so we can talk about this like this. C1Z equal to D1, C2Z equal to D2, A3X plus B3Y plus C3Z equal to D3. Okay, here you can also apply what? Okay, X is, it is also, I am considering only the non-homogeneous. Here D1, D2, D3 is not equal to 0. You know this. So this is non-homogeneous. So the solutions be X equal to D1 upon D, Y equal to D2 upon D, Z equal to D3 upon D. Okay, provided D should not be equal to 0. Alright, what is D1, D2? Again here the question is, what is D? First, D is determinant, the coefficient of X, A1, A2, A3, Y in the second column, coefficient of Y, B2, B3, coefficient of Z, C1, C2, C3 in the third. Okay, like this. For D1, remove the constant with first column. Okay, D1, D2, D3 and B1, B2, B3, C1, C2, C3. Okay, what is D2? Exchange B1, B2, B3 as D1, D2, D3, second column with D1, D2, D3. Okay, A1, A2, A3. Here you write D1, D2, D3. Okay, and the C1, C2, C3 as it is. And what about D3? In a similar manner, you have to place what? D1, D2, D3 at the place of C1, C2, C3. Okay, so A1, A2, A3. Okay, B1, B2, B3 and D1, D2, D3. All right, provided that D should not be equal to 0. So keep this thing in mind. Now what if D equal to 0? Okay, we are talking about what if D equal to 0. So here C3Z. Okay, D equal to 0. What if D equal to 0? Then, so since we are talking only about when non-homogeneous. Okay, so homogeneous. So here you see that D1 and D2, D3 are not equal to 0. So for non-homogeneous, so if D equal to 0, then at least one of the D1, D2, D3 are non-zero. Here, at least one of the D1, D2 and D3 non-zero. Okay, non-zero, then the given system is inconsistent. Okay, so we can say that given system is inconsistent. Here at least one of the D1, D2, D3 non-zero if you get, then the given system is inconsistent. Okay, if D is, the condition is if D equal to 0 and okay, and D1 equal to D2 equal to D3 equal to 0. In this case, you are not getting any, you are not getting all determinant 0. But here, if you are getting all the determinant 0, D1 equal to D2 equal to D3 0, then you can say that system has infinitely many solutions. Okay, what would write? Infinitely many solutions. Okay, so that means it is consistent. Can we say this? Yes, it is consistent. So we would use this property in a question. Which type of question you get? I'm going to write it for you first. Okay, so for what value of P is the system of equation and the system of equation of p cube x plus p plus 1 whole cube, okay, y equal to p plus 2 whole cube, okay, is 2 whole cube, and px plus p plus 1 y equal to p plus 2, all right, and x plus y equal to 1. So the question is, for what value of p is the system of equation p cube x plus p1 plus p plus 1 whole cube y equal to p plus 2 whole cube, px plus p plus 1 y plus p plus 2 equal to p plus 2 and x plus y equal to 1 consistent, okay. So consistent, so here we have to use this property, and for what value of p the system of equation is consistent. So this is consistent when d equal to, are you getting d equal to 0 or not here? Okay, we need to solve this first. We are getting d equal to 0. The question is, yeah, the system is consistent, we are saying. Okay, so the system is consistent when d equal to 0, or d1 equal to 0, or d2 equal to 0, or d3 equal to 0. So here system is consistent when d3 equal to 0, okay, because we have the when you find d3 here, you can say d3 equal to 0. System is consistent when d3 equal to 0. What is d3? d3 is actually when you write first the coefficient of x, okay, p cube, p and 1, coefficient of y in the second column, p plus 1 whole cube, p plus 1 and 1, and you do not place in third column the coefficient of z. Instead you place here d1, d2, d3, which is the constant, okay. So you would place here p plus 2 whole cube, p plus 2 and 1, and this should be equal to 0, since it is given that the whole system of linear equation is consistent, okay, and they need the answer of p, okay. So it is given that the whole system of equation is consistent. That's why we can say that d3 equal to 0. Since we need to find the value of p, so we need to solve this question, okay, this determinant. How would you solve? One thing, make these two 0. How would you make it? You can apply here c2 changes to c2 minus c1, and c3 changes to column 3 changes to column 3 minus column 1, because you cannot do column 1 change to column 3 changes to column 3 minus column 2, because it has been changed, okay, here. Now c3 changes c3 minus c1. So when you do this, you would be, so c1 would not change, p cube, p1, these two will become 0. Here you would do p plus 1 whole cube minus p cube, p plus 2 whole cube minus p cube, here p plus 1 minus p, here p plus 2 minus p, all right, equal to 0. Now what would you do? Okay, yes, it is visible. P cube, okay, p cube, okay, solve it. P cube, a cube minus b cube, a minus b, okay, when you solve this, now it is very easy, you can easily solve this. A cube minus b cube, a plus b plus b, what is b? A plus b, p, a square, p plus 1 whole square, a square plus ab, what is ab? It is p plus 1 into p plus b square, okay, a square plus AB plus B square. Here P plus A plus B is P plus 2 plus P, and okay, no, I think A cube minus B cube, it is wrong. A minus B, A square plus AB plus B square, A minus B, okay, like this, and A square, what is P plus 2 square plus P plus 2 into P plus P square, like this, okay. When you do the calculation like this, here P plus 1 minus P, you will get here 1, P plus 2 minus P, you will get here 2, and again what you would get here 1, 0 and 0. Now you have to expand it along with this column, sorry, row 3. When you expand this, you would get here what? Are you able to see or not? Oh, yeah. Column 3. Okay, you will get here plus, minus, and plus. So we would not work on this 0 and 0. Okay, we are only working with this plus 1. Okay, so write plus 1 here like this. Okay, and remove this row and this column. What would you get? P plus 1 minus P. You will get, solve this first. P plus 1 minus P, you will get here 1. All right. P plus 2 here, you will get here 2. Okay, and when you expand this, we will get something else. Okay, so 1, remove this and this row and this column. What would you get? P plus 1 whole square plus P plus 1 into P plus P square, and this whole P plus 2 whole square plus P plus 2P, okay, plus P square, and 1 and 2. You need to simplify this first before solving, because first simplify in the rough. Okay, after that put the value and have the solution also. You get P equal to minus 1. When you solve this, you will get P equal to minus 1. All right, so I hope you can solve this. My motive was only to introduce the concept, what the concept behind this, and weigh the use of this Crammer rule. So most of us, that means it is used in the application based question and the competitive exams. We use this type of rule. Okay, so we have a last question. If the system of linear equation, okay, the system of linear equation, it is x plus 4ay plus za, okay, za equal to 0, and x plus 3by, x plus 3by, x plus 3by plus zb equal to 0, and x plus 2cy, x plus 2cy plus zc equal to 0. What do you see? d1, d2, d3 equal to 0. So this is called homogeneous. Okay, homogeneous. So I did not explain you, I think. Yeah. So if you have homogeneous, so we have trivial or non-trivial solution in homogeneous. So if d is not equal to 0, here the case is if d is not equal to 0, the system of linear equation has trivial solution. Okay, trivial solution means you would get means x1 equal to x2 equal to, not x2, x equal to y equal to z equal to 0. Yes, this is the meaning of trivial solution. And if d equal to 0, what is the meaning of this? The system of that means it has non-trivial solution. And what is the meaning of this? Non-trivial solution means it has infinitely many solutions. Okay, so first we need to check it. This is homogeneous system of homogeneous equation. Okay, so first we need to check that whether D is equal to 0 or not equal to 0. So okay, keep this in mind. So let's solve it. How would you solve? This is, what about D? Did the 1 1 1 4a 3b 2c 4a 2b, sorry, 3b 2c 4a 3b 2c, and coefficient of z a b c, a b c. Is it right question or not? I need to check it. 1 1 1 1 1 1 4a 3b 2c a b c, all right, equal to 0. Okay, so should I, okay, so what do you have to do? Make this, these two as 0. How? This and this as 0. What would you apply here? So R2 change to R2 minus R1, and R3 change to R3 minus R1. So apply this. What would you get? The determinant changes to 1 4a a 0 0 3b minus 4a 3b minus 4a, and b minus a, like this, b minus a, and 0. This is 2c minus 4a and c minus a, like this. Okay, expand along column 1. What would you get? You would get here 1, this, remove this row and this column, so 3b minus 4a, 2c minus 4a, b minus a, and c minus a. Okay, no need to do anything because we have other element 0 and 0, so we have to focus on this only. So you'd get here left cross minus right cross, 3b minus 4a, c minus a, minus 2c minus 4a, okay, 2c minus 4a, b minus a. So do you think, do you have anything here? I think, okay, in order to solve this question, first you need to write the question first. So if the system of linear equation, this is a system of linear equation, have a non-trivial solution. Okay, we have a non-trivial solution. So non-trivial solution, so where is this? Non-trivial, just d equal to 0. We have given d equal to 0. System of equation of non-trivial solution, then a, b, c, r, then a, b, c, and r, you have to check. They have 4 options: AP to GP, HP, fourth, none of these. Okay, none of these. So you have to check it. Okay, so what is given here? The system of this equation has non-trivial solution. That means d equal to 0. It is given d equal to 0. So what did you do? What did I do? What did I do? Okay, equal to 3b minus 4a here. And what was that? C minus a. Okay. So d equal to 0. We have 0. So multiply this. 3b minus 3bc. Okay. 3bc minus 3ba. 3ba. 3bc minus 3ba minus 4ac, 4ac minus plus 4a square. Okay, multiply this also, take minus common as c, 2c square, 2c square minus 4ac. Okay, what is this? No, sorry. What did I do? 3bc 3ba minus 4ac minus plus 4a square. Here we have to multiply this. Okay, these two, 2c into a 2cb minus 2ca minus 4ab okay, and minus plus 4a square. Okay. Why I'm getting same question? Is it wrong or right? Anyways, so 3bc, when you change the sign here, first minus plus and minus. What did you get here? 3bc and 2bc. 3bc minus 2bc, it is bc, okay, bc minus 3ba plus 4ab plus ab plus ab. Do you have any b? Okay, plus ab. We have done with this. Okay, 4ac minus 4ac plus 2ca minus 2ac. Okay, and here we have plus 4a square minus 4a square, alright, equal to 0. This will be cancelled out. It is equal to 0 according to the rule. Now we have to check whether it is AP, HP or GP. Now we can remove these. Okay, we have to focus only on this equation, that what is this, is it in GP or in HP or in AP. So if suppose if A, B, C are in AP, suppose, okay, so what do you need, what do you find here in AP? So B minus A, common difference would be equal to C minus B. So here you get 2B equal to A plus C. So compare this. Okay, do you have 2B equal to A plus C? No. So this would not be in AP. So remove this, the first case. Okay, suppose A, B, C in GP, A, B, C in GP. Okay, so what the case in GP? That B upon A common ratio would be equal to C upon B. That means B square equal to AC. Do you have B square equal to AC here? No. Anyways, so this option B would not be here. Now what would you check next? Last, if you know that if A, B, C are in AP, then you know that A, 1 by C and 1 by C will be in HP. Okay, are in HP. Okay, harmonic progression. So 1 by B minus 1 by A common. Okay, 1 by C minus 1 by B. So here you get here 2 by B equal to, okay, okay, no, I did wrong. If A, B, C are in HP, okay, harmonic progression, then 1 by A, 1 by B and 1 by C will be in AP. So in this case, you know that in AP common difference are equal. I am only telling you the basic concept. So when you move this 1 by B minus 1 by C minus 1 by B, sorry, the common difference. Okay, so when you move this, you will get 2 by B equal to 1 by C plus 1 by A. So take common here. This is something like this. Yeah. So 2 by B equal to, when you A plus C upon CA, yes, we have 2AC equal to B bracket A plus C. And take B common here in this. Okay, yes, A plus C, yes. So we can say that this is in HP, this is in harmonic progression. Thank you very much. I hope you have understood all the questions. Thank you very much for watching this video. Thank you.